disassembling everything. I'm leaving this parts here. I'll put the motors inside that and put all that in my bag. We ship over first. Huh? It was hard. And then this the thing I just took hold. That's just I'm putting my bag.
You guys have these.
Sounds right.
Everyone's here? Okay, awesome. You want to
Yeah, that's fine. I can start.
stand in front?
Yeah, you can start.
Okay. All right, thank you so much everyone for being here. I hope you've had a good time in Goa in the last couple of days. Sure. Okay, nice. Well, all these young makers have been at it while you've been, I guess, having a great time. They've been working really, really hard, and I think you'll get to see some of their work today. It's been quite an amazing week. A lot of things have happened this week, and I hope you'll get to see that. Today is interesting because we like to call this day zero, and if somebody noticed that. The reason for that is that we believe that this is hopefully the beginning of their maker journey. This is not the end. This is now home for them. They're always welcome to come back over here and also explore all the other maker spaces and this maker movement in the world. This is just the beginning of what you see. This is hopefully not the end of what you're going to see. This is right where it all begins. Hence, day zero. Hey. All right. Okay, let's take a look at what happened real quick. We started off by getting to know each other. So just about 7 days back when everyone came here, that's when we pretty much met for the first time. We got to know them, they got to know us, they got to know each other. And now it's hard to separate them, which is nice. Really happy about that. How many of you helped another team? There we go. Good to see those hands. This space has always been about creating a space where people share and help each other. So it's nice. We discovered a lot of skills. We learned new skills from working with soaking irons to working with the wood lab. What do you guys think about the wood lab now? How do you feel with the tools now? Yeah, you feel good? How about 3D printers? Yeah, good. So we didn't do anything once again. It was them that was using all the tools, and now I'm very happy to say that they're safe to use a lot of the tools inside the shop. They know what is what, which is exciting. And to see them use it professionally, it's beautiful to see that. And to build that confidence, because a lot of times when you haven't made anything in the past, you feel unqualified sometimes to make it. And the only way to get that unqualified feeling out is to actually make something. And that's what they did over here. They built that. We discovered a lot of new tools, from 3D printing to electronics to working with that. We have a nice one over here. That's your glue gun. We spoke to more, learned different things. We had a board game night. How many of you are here for the board game night? Oh, how was that? Did you enjoy meeting the board game community of Goa?
Yeah.
Nice. Getting to see what's happening? Nice. We made a lot of pizzas as well. How many of you tried cooking? Not this time. Alright. And last time we also had a bear night. And everyone was at it. I don't know if you guys noticed, some of them were here till like pretty late at night. And it was quite a lot of fun. It was a little madhouse. We had a great time working with everyone. And also helping other folks out, fixing things. So all that you see is the magic of the last day. They also made some knives, which I'm secretly very happy about. But I won't say that. But they made knives with wood. I don't know if you saw them, but they were practicing their woodworking skills, trying to make these wooden little pieces that they were carving by themselves. That was beautiful to see. But don't worry, they weren't sharp. And they had a good time learning how to use the tools with it. And this is something that they put together. You guys still have them?
Yeah.
Oh, nice. What do you guys think about the knives? Okay. A lot of frustrating moments. So there is one God that we pray to and make the Salam, that's Murphy. We just hope that Murphy is kind to everyone today. There's a saying there's something called a Murphy's Law in our world, which is that everything, that's right, everything that can go wrong will go wrong. That's pretty much Murphy's Law. And well, in the world of engineering, in the world of making, that's one thing that you learn. That when you're trying to show something, or when you're trying to actually showcase your final creation or whatever you worked on for so long, everything that can go wrong will go wrong. And that's part of our life. That's part of the maker journey. And I'm really happy to see that they've lived that. They've felt the hardship, they've felt the frustration, they've had those difficult times, and they've had those confusing times. And they've had some amazing times as well, with, of course, a bunch of the mentors. So can we hear it for all the mentors? Let's just do a quick roll call over here. Anul. Let's go. I see Yash. I don't know if he's around. Is he? Not that today. Fennel. I don't think anyone else is there today. Everyone's left. Oh yeah, there you go. Anyone else you guys want to give a shout out to? Gunjan. Gunjan's not here. Okay. Daksha is not here. Okay. Well, it was really fun to work with all of them and also to learn alongside them, because honestly, all these projects are new for us as well, as much as they are for them. So every project is a new challenge, not only for them, for us as well. So it's really fun to work together and learn. Yes, and of course, we did a lot of making, and you're going to hear that from them and see what they've come together. So I think, without any further ado, let's call upon the first team, Team Cohort. Yeah. Okay, so that phone is live streaming, so if you guys want to come in the center, come over here. Come over here. You can stand over here if you like. I'll put that in. Why don't you come over here? And there you go. think it's wrong way. Let's no, one day. Oh, it's taking out from one day.
So we should have it.
Okay, is it on? Check.
Hello?
It's on.
No, not that.
No, no, that's on.
Yeah, not the soda.
Okay, for my laptop. Uh, I'll just connect.
That's not real vodka.
It's already on. You need your laptop? Yeah. Let's get started quickly.
Get started. Oh, it's very light. It's okay. It's okay. Yes.
What's going on, guys?
So, our project is called the Barboard. It's basically an automated drink dispenser. We'll hopefully be able to give you a taster after this.
Okay, so let's start with the problem. Initially, when we were coming up with ideas on what we will make for the robot, one of us were injured, and we didn't like it that our mother and people who were close to us had to go get drinks for us and do the things for us. So we wanted to make a way to automate all of that. So that's where the idea of the Barbot came from. Of course, this was before we knew that they had a completely functional robot in the back, but we feel that we've made a better version.
Okay, so the Barbot is designed to make mocktails and drinks for you at your convenience. And so basically, what's the advantage of using the Barbot is that so each thing has been measured precisely, like how much liquid will be put into the glass and how much will be made. And since it's all automated, there's very little room for error. And it's like perfect to use at home, just as a not as a decoration, but it looks good as well. I mean, this is a prototype, but could look better.
These are some key features of our robot. So it can be controlled using the serial monitor on this laptop. You can customize the ingredients to however you wish, and recipes are all editable, and it's pretty simple to use.
So the fact that it was editable and customizable helped us a lot because we were able to tinker around in the code, and because the things could be changed very easily with the motors, it made it very easy for us to pick and choose what ingredients we would like to give you guys the best drink we could come up with.
This is our circuit.
So yeah, I guess the working one is in there, but this is how the plan of the circuit was.
So the text is proper. In the folder.
Even for this slide before. It's a photo layer. This is not our fault.
Keep going.
Okay, so basically we tried to make the design and the working of it pretty simple. So what happens is on the laptop itself there's something called the serial monitor where you get an output from the computer itself that will allow you to click on a certain. So basically we made a menu on the laptop itself, and then when you press the enter button with the number, it'll give you that drink. And yeah, and so currently it's from the laptop, and the laptop has to be linked to the microcontroller inside. But we tried working on an Android app, like you can control it wirelessly. But since this is just a prototype and we had to do a lot of troubleshooting, that didn't really work out.
But because we're using an ESP32, we will be able to do that. Here are some real-world use cases. You can use it at parties, gatherings, at home. You can keep it as like a showpiece to show people what innovation you made. Yeah.
Actual bar and okay. Basically here in this slide we're talking about our future developments. So one of them would be we're working on a web page. So it's currently the text is white, you can't see it. And we also wanted to make our component 3D printed instead of like carved out of wood. Oh yeah. Yeah, 3D printing and then facial recognition, so it already knows what drink you like. And you can like
You can check your drink history. Yeah. It offers personalized suggestions based on your drink history, and because of the facial recognition, right when you walk up, the robot will already know what you want. We'll show you a demo now.
You can call someone from the audience to have a drink.
Who wants to come and try it out?
No, not these guys.
Anyone from
One of the parents needs to try this out.
any volunteers?
Yeah.
Fully. No one's right.
Safe, that's right.
This is at your own risk, okay? Just disclaimer, Amical Asylum is not involved in any legal processes post this.
These are the three options.
So there's a tropical sunset, mango kokum cooler, mango lemon zing, and triple twist. Which one? Okay. So since the tropical sunset is number 1, so you just press 1. That's cool. Yeah, mango lemon is the first one. Yeah. Okay, so now you just press 1 and enter. If you can, yeah, just if you can see the mangoes coming out.
Beautiful.
One by one. That was a mango. Now this is the lemon, I think. Yeah, put it out. Yeah, now the water will be coming. Yeah, it's done. Does anyone?
Later. Everybody can have a drink later. You guys can take this. You can leave it in the corner. You can take it back in the kitchen. Yeah.
Let's serve it both like pots. Let's go. No, let's go.
Alright. What do you guys think? Any questions for this team? Any questions for these guys? Okay, we've got a question.
Do you plan to change the way it looks, and will it have ice for the summer?
So basically we wanted to make it look better than this. But what happened? So our initial design was much different than this. It was flipped around and it was like about this big. But then we had a lot of problems with an overflow because of gravity and cycling error. So we had to change the design. And we didn't really have that much time to make it look better, but yeah, that's the best we could do. And for the ice, what we've done is we've tried to add cold ingredients instead, because now like the point of it is to be automated, and we couldn't really figure out how we could get an automated ice as well. Like add ice automatically. So yeah.
But something to think about for the future. Yeah.
For sure.
Awesome.
It's okay, you can, I think it's time for the next team, but you guys can show the making and what you're up to now.
Yeah, everybody can check their projects out in the kitchen.
Okay,
Okay, let's do the next team.
next team.
Okay. Yeah, next up we have pulsing. Yay! That's our only girls team for this cohort.
There you go, that's for your slides. Next, we got
These are your mics. Yeah.
Okay, so I'm Anya.
And I'm Roshi.
Okay, so I'm sure everyone here has faced some level of stress before, whether it's just school or work. But it might not be, it could be known, but anxiety and stress is a big and major reason for heart-related issues everywhere. It can lead to unhealthy habits such as overeating or undereating, consuming excessive alcohol or smoking. It can also lead to temporary spikes in blood pressure and could also increase inflammation in the body, specifically blood vessels. So these are all problems that could result in health-related issues. And this is where Pulse Sync can help. She'll be demonstrating while I talk. So there's a heart rate sensor at the bottom, which is connected to a display and an LED ring at the top. So if the BPM is in a good range, it would be green. Right now it's not, so it's red. He's strapped moreover, if it is unhealthy, it will showcase some immediate remedies that could be used to solve them if it's not an emergency situation. And then if it is for a consistent period of time, it would direct them to contact emergency. We had a lot more plans for this, but we couldn't execute them in this week. But we wanted to connect it to a website or an app so that you could input your age and weight and things like that, because they affect what is considered a good range for BPM. Moreover, if it was connected, it would have been able to connect to your emergency contacts so that they would be alerted in case something goes wrong. And finally, something we've been working for a while, but then it didn't work last minute, was a vibration motor at the edge. So that in case you're not paying attention to that LED, you would be alerted through that.
Okay, so through the whole process of making this, we went to ideating a lot of problems, and all of these health issues were mostly leading to heart attacks, which is why we chose that as our main problem. And one of the symptoms that Anya talked about was
Anxiety and stress that is faced by everyone around here, and most of us in the age range from 13 to 16. So this is a device that allows the user to understand what their heart rate is and how different measures can be taken. So at the start, when we started to figure out our process, it started to get difficult because when we started connecting the sensors together, it became difficult because sometimes the code wasn't working or the wiring wasn't right. So it blinks like this if the BPM is good. And as you start connecting the sensors and all, first we had an issue connecting the OLED and the heart rate sensor, as it was not showing the correct values and the values were fluctuating a lot. So we asked the mentors and we went through different codes again and again, which took a lot of time actually. And in the end, we were able to reach the solution there. And I'm against.
What's happening?
Yeah. And as we went, but then we were able to complete the first prototype. But as we went through again, till then our smaller microcontroller had reached. So we were back at square one again because we had to do the circuits again because there were little storage on it. So the OLED display did not work again, and even this now the LED ring did not work at all. So we were into that problem again and again. Till the end, we were able to fix out the problems, and then the major problem that came in the end was choosing whether to use a perf board or soldering the wires. We chose the perf board instead of soldering of the wires because the wires could have got jumbled up, which may have led to the display getting overheated or the ring LED taking too much power. So the perf board was the better solution. And as we were going through all these codes and all, we even thought that why only warn the users and not tell them what needs to be done until a first aid remedy comes, like a first aid or an emergency contact reaches you. So if your BPM is lower than 60, then it tells you to splash cold water, and if it's above 100, then you need to take deep breaths and meditate to get it into a good range. So the age group that we've chosen is 13 to 60. and the good BPM is like 60 to 100, 60 to 100 beats per minute. Yeah.
Any questions for the team? No. Any questions for the team? Any questions?
Hi, I have one question. The sensor seems to be outside at the bottom. Will it be waterproof? Because especially if you're like walking around in Goa lanes, that's not going to survive.
So we haven't discussed that part yet because this was just a prototype yet. So I think we could have made a cover. We have actually encased it in a cover here. We've actually encased it in a cover here which allows it to be around your wrist all the time and does not let the water enter in. So we might look for another sensor which is waterproof.
Any more questions? All right, great job, girls. Okay, next up, Beba, what's the next team?
Plastic control. Plastic patrol.
Plastic Patrol. What's happening?
Oh wait, sketch vendors.
Sorry, sketch vendors.
What are sketch vendors?
Hi, I'm Vedant. I'm Krish.
I'm Raghav. And I'm Prabhav.
And together we are the sketch vendors. So Krish and I have worked on the software and debugging part of this.
While me and Prabhav mainly worked on the hardware.
Okay, so now we come to the problem. Braille and embossing systems are super expensive, hard to find and complicated to use. So our solution is an innovative method using a new pen mechanism that makes drawing and Braille easy.
So for the preview, you have to wait.
The seventh slide is.
Can you move it?
So now we just go on to the main parts of the actual machine. The first part is the actual microcontroller, that's an EBB board, with a motor over there, that is the modern PMAX-17. Then we move on to the pen holding mechanism, which works through a servo motor, that is the MG90S Tower Pro. Then the actual motor belt, which is the thing that actually moves the pen mechanism as a whole.
So here you can see this is the preview. So can you play it?
That's nice.
Look, I just play it. So here in this video, this is one of our first attempts of actually using the board, and this was unsuccessful. As you can see, the board malfunctioned. We were trying to make it draw a circle, but it was just making continuous diagonal lines because the motors weren't working.
And
so here this is one of our most complex drawings we created with the board. So it was, can you guess who this is?
That's
Oh yes, it's very so everything was able to work by the end of the program and we were able to create this drawing.
We also have a rail, it's like a preview of the rail that we were able to create. It's not working currently because some glue actually blocked the holes. Yeah, okay, so this is a timeline of the different problems we faced through the creation. At the very beginning, while creating the actual motor belt, it caused us some issues due to the fact that it was quite loose and that didn't allow the motors to turn it properly or the pen mechanism to move on it. Another problem we faced was actually that the universal G-code sender, which tells the pen where to move, was not connecting to the EBV board itself, which didn't allow us to communicate with the pen, even though we tried multiple different laptops or different softwares. So again, this compatibility for the software was a big issue that we faced due to differences in the board and the fact that there was no documentation for this custom board online. And we found that the motor driver, which is the monstrosity, which you can see in the photo, was already fried, and hence it didn't actually work correctly. Due to this motor driver not working correctly, it actually caused a huge short circuit, which caused a crucial part of our circuit to go to complete trash, and it made the bot not work correctly. Also, Vedant's charger got fried in the process.
And after this part, we were completely shocked. We had no idea what to do. We had to replace our motor drivers, even though we couldn't find a single replacement online or even in the nearby local shops. We were completely stumped.
We tried everything to fix the problem, from switching the motors to even the board, but nothing seemed to be working. Until finally, towards the end of the program, we found a ray of hope. After searching the asylum, as you can see there, we found a similar larger version of the board that we were using. So we opened up this board and took out the motor drivers and replaced it to finally get our smaller board to work for the first time.
Right, so our solution was basically we got the complex joints to work. We got somewhat of the brain to also work after all of our troubleshooting, all of our debugging. And yeah, so that was final what we were able to do, like that it worked. But even like after that we did face some issues that we will continue to work on.
Thank you.
Thank you.
I have a question, guys. You did not tell us why did you do this project? The user. I mean, what was the idea behind it? I mean, I know you did, but like why?
So we had a couple of different reasons why we wanted to work on this project. One of the things is that I think Vedant mentioned it slightly at the beginning. These kind of bots can be extremely expensive and difficult for users to interact with and actually use. And this makes it much harder for those with visual disabilities to be able to interact and with these kind of things, like especially with art and things stuff like that, which requires a sight to be able to appreciate. It's something that we found that we could actually create that thing using indentations in the paper.
Nice. Any other questions for the team? So for making art inclusive is what you're saying?
It was one
of the reasons, right? Got it. Nice.
Thank you.
Awesome.
Set it up for demos later.
All right, next up. Plastic patrol. Let's do it.
And that's the presentation clicker. You guys can split like two people here, 2 people there, maybe.
Hi, my name is Aditya.
My name is Leon.
My name is Soham.
And I'm Rishikesh.
You can take that one. It's so, one second, let me turn it off. Yeah.
So our project is the plastic patroller, and it's essentially made to clean up plastic waste on hiking trails and stuff like that. Like
nature, national reserves.
So basically, this is a table of contents which we covered across the whole project. So, we're starting off with the initial vision and the problem statement. So basically, this robot, okay, it's a really complex mechanism. It consists of a chassis and a bucket. So basically, the chassis, it's a part which has tracks. So basically, it's able to move on any rough terrain you can find. Okay, and it's able to. So our sensor is able to detect any material, and according to the material we have, it's able to detect whether we should pick it up or not.
So the central part of our board is the NIR sensor. So the NIR sensor uses infrared spectroscopy to differentiate between organic matter and plastic waste. So what we have done is we have used the sensor to differentiate, and then we've used 2 servo motors and a bucket to help scoop it up and put it to the pack.
So we use CAD and computer-assisted design in various parts of our project. So basically, while we were making this, we 3D modeled the excavator bucket, which is the part of the mechanism which is picking up the waste. So basically, we had a lot of trouble in the beginning. Our bucket was way too heavy, so it wasn't able to, the motors weren't able to lift the bucket, so it was too heavy, that wasn't working out. So, and also we were designing various other parts in order to prevent the bucket from pushing materials, and we wanted it to pick up materials, but it was instead pushing them. So that was a very difficult part of the project. And we also laser cut various other parts like the teeth and the handles.
Continue.
Yeah, I have it on my laptop.
Okay, so now this is going to so basically when it comes to mobility, we bought a kit online which had the body of the patroller and these treads, and it came with its own motors, and so we used an ESP32 to control the whole thing, and we had a controller module which was connected to both the motors. Now we had a lot of issues with like power, because we're giving it 24 volts of power. We have different power supplies, and we're probably, this is our 3rd controller module we're using, because we kept burning it, and yeah, there's like a huge like those wiring wise, it has a lot of wires, and getting the code working was quite a problem, but luckily our mentors helped us out, so thank you to all the mentors. And basically the controller modules, like, let me explain all the parts. So the ultrasonic sensor, it uses I have it here. Yeah. Oh my bad. Ultrasonic sensor uses sound waves to detect motion, and the controller module ensures that nothing burns out, because we're giving this thing 24 volts of power. Okay. And we didn't want our ESP to burn out, and so the way it moves is, and the way it's programmed, is that the bot will continuously move. It'll keep moving until the battery drains out. And let's say it senses something in front of it. It will turn one motor anti-clockwise and one motor clockwise, so it can rotate on the spot and then continue moving. Yeah. So we need volume.
I can pass that around.
Yeah, okay. You can just pass
Yeah,
it
just
around.
pass it around. Yeah. Okay.
So the bot is actually, it uses 2 ESP32s, the second one's for the NIR sensor, and so you could say the bot is divided down into 2 different parts. And yeah. Okay, so yeah, I think I've already covered this. So you want to talk about the front end?
So in the final product, in the end, it was mostly successful. We were able to get the patrollers to start moving in all directions. The only problem was the scooper and the motors in the end. So the weight of the bucket was always too much for the motors to handle, which is why we had to create a really light foam bucket. So in the end, I think this will be a really good prototype, but we can definitely develop on this a lot more. Yeah, most of it was yeah.
So these are just some of our project now it comes back. These are some of our project credits. So if you want to read.
So this is a prototype and we have been designed and even assisted in the presentation. So I've handled the entire body, the entire chassis was all Soham. We in Residency’25, we fixed the sensor and we also 3D designed a lot of the presentation.
Yeah, I think that's it.
Yeah, questions.
Yeah, I can grab that up.
Any questions for the team?
Okay, last one. Katie's side. Katie's side? Inside?
Katie inside. Yes. All right, Katie inside. Last but not the least. Please come up. At the bottom. I think there's one plug at the back. There's one plug at the back, Charan. There's a plug at the back. Please plug it. Yeah, it's right up. Yeah, just one side.
I'll just allow your slide.
Yeah. Good afternoon, everyone. I'm Vedant Agarwal.
I'm Devdas.
I'm Vedant Agarwal. I'm Pranay Singhal. And together we're Katie Inside. Yeah. So, the purpose of our project, I want to ask you everyone a question. Who's the backbone of the Indian economy? Farmers, right? So, the goal for our project was to help make farmers achieve different things. Those are better yields, more sustainable farming practices, and helping them use the latest technology. So with the help of our bot, we're able to increase the farmer yields because our bot basically tracks the soil health and it gives that to the farmers. So when the farmers have a better idea of what's going on in the soil, how much more water the plant is needed, I think that helps them give them better yields. And it's also a more sustainable farming practice because I think one thing which is huge in Indian farming is farmers overwater their plants because they don't know how much they're supposed to. And maybe when using a bot, they'll have a better understanding of we should be watering our plants this much less instead of so much. And yeah, I mean, it gives them access to this technology which most farmers are not even aware about. So I think that's what our main purpose for this project was.
The vision of our project is just to help Indian farmers get more sustainable and have a better life, which is more economic. And we want them to be sustainable in their practices because you just saw the rain outside. It was caused by climate change. It's not natural. And we want to reduce that over time. And this is one of the best ways of doing so. because the soil is the base of all farming and everything related to making crops for us. So if we enhance the quality of the soil, we will be able to increase the yields and economic viability of these farmers. This is the initial prototype we made. It was made of Lego, so just like a test to see what works and what doesn't.
Okay, so we faced multiple challenges while building this robot. The first one was coding, because none of us really had that much experience with code. And as makers do, we learned how to code, and with help from mentors such as Fennel, I can proudly say that the code on our bot works, even after countless iterations and enormous amounts of upload time. Then wiring was another issue we faced, because you cannot make big mistakes when you're wiring, because you will release the magic gas and your component will get fried, and there's not an extra one, there's no another tag drive. So we tried using programs like Fritzing, Autodesk Eagle and Tinkercad, but they either didn't have the components we needed or had a different version that wouldn't work.
Wiring is also quite a mess if you take a look inside. It's all jumbled apart, so I think that's something we also need to work on.
Finally, we used Circuit Designer, and I mean, on paper it looks quite clean, but it's not. Then power supply was, I think, an issue that we grossly underestimated. When planning for this, we checked the description of the motor and saw it's a 9 volt. It can accept anywhere from 5 to 8 volts. So we bought a 9 volt battery and we thought that was the end of it. But in testing, when we were making the motor move, I think we emptied 4 9 volt batteries, and even now it's connected to the wall because we don't have a power supply that can produce enough power for a long enough time. So I think that's something we can iterate on later.
The 4 batteries were used in the matter of 5 minutes, not a day.
Next slide.
This is a snapshot of the code. So essentially what the code does is that it allows the bot to move in one direction. Then using this actuator, the soil moisture sensor can move down. So you can measure the soil health and then it comes back up.
This is the wiring we were talking about. This is made on circuit. But as you can see, it doesn't look like that remotely anywhere close on our actual robot because all the wires here are bent perfectly. But in our robot, you probably have seen a cleaner teenager's room. So, thank you.
We'll try to do a small demo if we have the time.
Yeah, you can.
So till then, I think we can take a few questions while he loads it up.
Yeah, any questions for the team till then?
How do you plan to clean the sensor?
We were planning to use a toothbrush to put on the side of it. So once it goes into the soil and comes back out, the toothbrush cleans off all the soil. Yeah. Yeah. So our robot moves forward, and then yeah.
Might take a second.
Yeah.
Oh, there you go.
We must have just gotten a temperature reading if you could check.
So over here we have a temperature sensor and this is our soil sensor. And I think You can show the data which must have come through. Yeah.
Oh yeah, the keyword repeats.
Yeah, so
It was originally supposed to be autonomous without the wall connection. It will just go forever in a straight line because how long farms are. But that's not possible right now.
Yeah.
So over here we have our soil moisture.
We got 4, but there's no soil.
There's no soil I'm measuring.
The temperature is over here.
31.
Yeah, 31.
Yeah, it is. But yeah, that's it really. So thank you.
Amazing, thank you. What do you guys think? Awesome, right? Good job to everyone for you. So, great job, guys. All of this is possible just in a week's time. In this week, they not only learned how to use these tools, understood a little bit of this world and this culture, but also made something really exciting. And as you can see with all their projects, they are raw, they are real, they're not made out of any kit. That is something that they've actually put in a lot of hard work to try and make work and put together. And a lot of times, as you guys know, in real life, that's what it's all about. Trying things, having them not work, that's real life, right? And then learning from it, and then making it better. That's pretty much what happened this entire week. We were just there to support them whenever they needed us. But apart from that, it's all their work. So once again, big shout out to all of you. Okay, well, a little bit about what's next. Well, of course, as alumni, you have lifelong access to the asylum. You are now all officially M1 level makers as part of the Make It Journey. So keep coming back, keep making, keep building stuff wherever you go in life. And there are maker spaces in different parts of the world, and you will be able to, I hope you discover this culture as you go along. Your maker passports, use them. Try and step out into other maker spaces, try and see what this all culture is about. My personal journey is that I never fit into school. I moved 4 schools in the same city, almost got kicked out of all of them. But then somehow managed to get into a great university in Boston and worked at different labs and maker spaces, and that's where I pretty much found myself and folks like myself. So I really love this culture of building in an open environment and sharing, because that's what these spaces are all about. Yes, of course. Back to Richa, she can share more.
Yeah, before we share the certificates for the parents, we will take you through this quickly. So what else can you do at this space now? You can be part of more programs. So we have a lot more programs apart from the Innovation School. Makers Asylum has been working across board with a lot of different universities. We work a lot with UN agencies. We work with a lot of corporate partners as well. So there's a lot of different kind of range of stuff that you can do. This is one of our programs called SDG School. So right now they build something that they wanted to build. This is something that you want to build for the planet. So that's something that you guys can also check out. We're going to be doing this cohort soon. We also have level up immersions where you guys can come back and work on either your current project idea or a new project idea. Now you guys know how to use all the tools, so we don't need to teach you that. What you can come in for is the facilitation, the mentorship, the access, and things like that. So we'll share the level 2 immersion options soon with you, so you can also come back. You can also become an alumni mentor and pass it on. So come back and actually help the next cohort with their projects, because what happens is when you help is when you learn more. So that could be another thing that you could do when you want to come back. You can also volunteer and intern with us on our research projects. So a lot of our work is also focused on using the maker community to actually look at and implement project ideas on the ground, which are open source in nature. So you guys can be part of our open research work as well, which we can share with you. What can parents do? Well, Makers Asylum started as an adult space only actually, back in the day in 2013. The 13 and above is just a very recent addition. So it's always been a space for all people from all disciplines, backgrounds, and ages to come and actually learn about making. So you all can also come and learn about making. One of our really fun course, which a lot of people do from across the world, is our woodworking workshop, where you can actually build your own furniture. So maybe you can start with that. But apart from that, you can of course be an ambassador and evangelist for our culture and our space. If you feel like this is something that needs to exist, please make sure that you talk about it, because it's always been kind of word of mouth for us. So we love for you to spread the word. We also do a lot of, now I just wanted to also share this. Over the last 3 years of Innovation School, we've actually had over 400 plus talents in the program who've come to Goa and actually learned at the space from over 50 cities. So it's been becoming very diverse and a big family of people. And also 15 countries now, so it's also become really amazing and international. And we also do a lot of social impact inclusion work through the program. So if you feel like you want to contribute for somebody who cannot afford the program, or you want to support them, please reach out to us. This year we have a target of supporting 100 underprivileged students. So if you feel like your friends and family can contribute to our cause and have access to the same program as your children did, they'll be lovely to kind of contribute as well. What I wanted to say was these programs like these, like the alumni of the program, I did present the makeup portfolio and pieces like that to these guys. But this is a life skills program in general, and also a really great career exploration program. A lot of the students who are part of the program go to some incredible schools, universities, because they've really identified what they want to do. And a lot of our alumni have gone to some great schools, so we hope that all of you are going to be part of that big journey as well. Makeup portfolios have become really a big deal when it comes to university applications, especially in STEM. MIT started it originally, now everyone's following suit in the US. I don't know if anyone's going to the US anymore. But there's a big makeup culture in Australia, in Europe, and every part. So actually it's sort of pan across. But we also look at a lot of exposure opportunities where we do our summits and acceleration programs where we call specific projects to come back. So please do come back for those when you're called in for. And the program is not just for high schoolers, it's for everyone. So anyone looking to kind of build and make, you can join it. I want to share one impact story that came out of the program. These guys were part of our first cohort. And they started, so Naman's from, he's from Bombay, he's from one of those IB, Dubai Money, school, etc. Very smart kid. Ganesh is from our social inclusion group. His dad is a carpenter. He came to us from Teach for India. They both got together. Now they're kind of building this drone delivery startup out of Bangalore that just raised $2 million. So, it's one part of the impact that can also happen eventually, but the community in itself is so fundamentally strong and like-minded, you can see good things happening in the future as well. So, so we're building the future with all of you together. And our next cohort is also starting soon, so please feel free to spread the word. But that's about it from my end. Thank you so much. Let's get the certificates out.
Yes, but to the certificates, then before that, let's not forget to take a photo.
Yeah, of course, we're going to do a photo op with everyone. We're going to come and can I have the mentors and the team kind of come in? Where's Annette, Rishi, Ajit, Fennel? Come, let's give it one by one. Come, Fennel, why don't you start? Alright, Pranay, please come and pick up your certificate. Come here. Okay, just 1 minute. Charan is just placing himself for a photo ops. Awesome. Nice. Next up, Dave Lavsibala. Okay, big claps everyone. Come on, let's go. Alright, Vedant Agrawal. Okay, Vedant Agarwal. Alright, and I'll come. There's so many Vedants in this batch. This is Vedant Garg. Okay, Prabhav Joshi. Raghav Kartika Majid, why don't you do this one? Krish Kapoor. Sabir Sulamki. Alright, where will you go next? Anul, come. Jwal Patel. Shimmer is Israni. Ryan Augustine. Aditya Mamin. Rishikesh Sijim. Soham Chakraborty. Rajdeep Kaur.
These girls put in a lot of effort.
Yeah. Most sincere team.
Yeah.
And Anya Patel.
Congratulations, then well done.
Alright, with that we're going to do, before you guys disperse, we're going to do a quick photo with everybody. So all the parents, everyone please, on this side.
Alright.
Let's do it.
Let's do a photo.